Alright, so let's talk about radicals. They're pretty great. They're pretty rad. They're cool. Okay, so when it comes to adding and subtracting radicals, all you gotta know are a few properties they kind of have, where all you gotta do is simplify under the radical, which is the same as taking whatever integer is under the radical and factoring it out to its basic components. And what you could do is when you have things that can be square rooted, you can pull them out from under the root. Like how root 27 is the same as the square root of 9 times 3, and 9 is 3 times 3, so that comes out from under the radical, becoming just a 3 because it's square rooted. So you got a 3 and root 3. Bada bing. Alright. Once you do that, you're probably going to have a bunch of radicals. Some will simplify down different than other ones. You might be left with a root 2, might be left with a root 5 or something, and you just have to combine like terms. In this case, we have a 3 root a being an arbitrary variable plus a 2 root a, and all you gotta do is combine them. This is another one of the properties. This becomes 5 root a. Alright, now we got some different terms here. We got 2 root a root b plus 3 root a. 2 root a plus root a. You combine the like terms. Can't combine the root a and root b because they're different terms. Bam. Alright, let's try another example. This time, we'll put some real numbers in there. 3 root 27. Always a good time. dt. This negative 6 root 8. Alright, now let's do our mathemagic on this. Take them down to cancel town. Got a 9 times a 3. Root 9 times 3. Same as root 3 times 2 times 3. Which a 3 times 3 can come out from under the root because it is square rooted, leaving you with a 3 times a root 3. It should be 3.
Nope, it's not 3.
It should be 9. Got you. Did not see the coefficient at first. Alright. We got root 9 times 2. Root 3 times 3 times 2. With a 3 times 3 can come out from the root. We have your root 2. Okay, 8. 2 times 4, which is 2 times 2 times 2. What happens? The 2's come out. Alright, you got a 2. Oh, can't forget the coefficient. You got a 12. Root 2. And now what do? You gotta combine like terms. 9 root 3 plus 3 root 2 minus 12 root 2. You get 9 root 3. And a 9 root 2. Now you can also do this with different kinds of roots. Same kind of idea. It's good to know how many components it'll break down into. This is where you gotta know your multiplication tables, kids. Alright. If we're talking about a cubic root, that's a pretty common one as well. And then we could be talking about maybe more complicated ones, but really they don't get much different than that. So when you combine the 2 cubic roots of a, can't combine combine the cube root b, not a cube root b, sorry, a square root b, because it's not a cube root. Can't combine it, they're not the same. Okay. Let's have an example. Examples are good. Got 3 times root 16. Nope, that's a cube root 16. My mistake. 2 times cube root 54. And square root. Now let's see what we can factor out here. 8 times 2. And what do you know? 8 is a perfect cube. So what can we do? We can pull out that 2 from under the cubic root. Bring out the 2. Is there 3? Or is it just a cube root? Oh. Alright. Bring out the 2. And then we got a cube root 2 still left inside.
Looks really big.
54 factors 2, 27 and 2. Well, guess what? 27 is 9 times 3. You know what that is? That's 3 times 3 times 3. You know what we can do there? We can pull out all those 3's from under the cube root. You know what that becomes? 3. Multiply it with 2, the coefficient already there, and bam. We got 6 cube root 2. Let's see. 4 times 2, which is 2 times 2 times 2. What can we do? Well, this one isn't a cube root. It's just a square root. So we pull out a 2. We got a root 2. Alright. Now let's combine us some like terms. What do we got here? 2 and a cube root 2. That's 6 cube root 2. We can combine those. Got 8 cube root 2. Plus a 2 root 2. And that's as far as it goes. Bada boom. Radical, we're talking about square roots.